Welcome to the mathematics in my channel. In this video we are going to solve this interesting Jee Advanced model integral from 0 to pi inverse tan of 2021 raised to the cosine of x dx. Well, how to begin? Okay, we can try with here 2021 to the cosine of x, so we can try with u substitution. U is equal to cosine of x, then we know we can isolate the x is equal to inverse cosine of u, then differentiate dx is equal to derivative of cosine of inverse cosine of u, we know minus 1 over square root of 1 minus u square du. So now we can plug in here. Therefore here integral from, now we should change the boundary. When x approaches to 0, we know u approaches to 1. When x approaches to pi, u approaches to minus 1. Then here arctan or inverse tan 2021 raised to the cosine of x, we know u, times dx we know minus 1 over the square root of 1 minus u square times du. Okay, then we can interchange this boundary. When we change the boundary, this minus sign get cancelled, so we have minus 1 to 1 inverse tan of 2021 raised to the u over the square root of 1 minus u square du. Well, then I am going to break the limit, split the limit, like minus 1 to 0 inverse tan of 2021 raised to the u over the square root of 1 minus u square du, plus then we know minus 1 to 0, 0 to 1. So here we have the integral 0 to 1 inverse tan of 2021 raised to the u over the square root of 1 minus u square du. Now for this integral I am going to take a substitution. So instead of u I am going to take, minus t, then differentiate du is equal to minus dt. Now we should change the boundary. When u approaches to minus 1, we know t approaches to 1, so here 1. When u approaches to 0, t also approaches to 0. Then here we have inverse tan of 2021 raised to the u we know minus t over 1 minus u square, we know t square, times du we know minus dt, plus I rewrite this integral 0 to 1 inverse tan of 2021 raised to the u over the square root of 1 minus u square du. Okay, then here again we can change this boundary, and when we change the boundary, we know this minus sign get cancelled, so we can write here now integral from 0 to 1. Now here this integral, the variable we have dt, and here u du. So we know the definite integral independent of the variable, so we can write instead of t we can plug in x, also instead of u we can plug in x. So here we have inverse tan of 2021 raised to the minus x over the square root of 1 minus x square dx, plus here also we have 0 to 1 inverse tan of 2021 raised to the x over the square root of 1 minus x square dx. Well, then we know I is equal to, now I is equal to, here we have limit 0 to 1, here also limit 0 to 1, so 0 to 1 we know 1 over the square root of 1 minus x square is a common factor, and here we have inverse tan of 2021 raised to the x plus inverse tan of 2021 raised to the minus x dx. Okay, then we know about this formula. Inverse tan of x plus inverse tan of 1 over x is equal to pi over 2. So when x is greater than to 0, we can write inverse tan of 2021 raised to the x plus inverse tan of 1 over 2021 raised to the x is also equal to pi over 2. So here we know this is also equal to inverse tan of 1 over 2021 raised to the x. So this is equal to, we know, pi over 2. So we can write now I is equal to this is pi over 2, and we know this is a constant, so we can write outside of the integral sign, and here 0 to 1 dx over the square root of 1 minus x square. So now if we take the antiderivative, we know derivative of arc sine of x is equal to 1 over the square root of 1 minus x square. So we can write this is equal to 5 over 2 times inverse sine of x from 0 to 1. And if we apply 1, inverse sine of 1, we know pi over 2. If we apply 0, here 0. So 5 over 2 times pi over 2, we know 5 square over 4. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.